This video is for Natalie. 11.5 day 3. Talking one to get two more things to talk about here. In 11.5 we have expected value given a probability distribution, and then we're going to talk about outliers again. So let's just jump right in. I skipped a page on the notes that you have, so we are going to just jump right into a probability distribution. And so a probability distribution is a table that gives you each outcome that's possible and a numerical value of that outcome. So in this case, like he made 0 free throws. This is a situation where maybe somebody got fouled, 3-point shot, and then they get 3 free throws. I learned that last hour. So you get 3 free throws, and the probability or the possible outcome is you make 0, 1, 2, or 3 free throws, and the corresponding probabilities are in the table. So the probability of making 0 free throws is 3/20, 1 free throw is also 3/20, 2 free throws is 1/5 or 4/20, and 3 free throws making all 3 is half. So what would be, if you just had to say, what's the most probable outcome here, what would you say? A half is not an outcome though, it's a probability. So the most 3. So the most common is for someone to make all 3 free throws. But if you had to say what would the expected number of free throws be, and you could calculate that to like the nearest tenth or something, I would say somewhere between probably maybe 2 and 3, don't you think? Okay, so what we're going to do is we're going to calculate an expected value, and it's kind of like calculating an average, sort of. And so what we'll do here is we will take, well, first of all, we use mu. Remember mu from last week? So mu, it's like half m, half u. Mu is the expected value, and what we're going to do is we're going to take each outcome value, in this case 0 free throws, times its corresponding probability, 3/20, plus the next outcome times its corresponding probability, and you do that for every possible outcome, and you find the sum of each of those products. So in this case here, we will be adding up 0 plus 1 times 3/20 is 3/20, plus 2 times 1/5. 1/5 is 4/20, so that's going to be 8/20, plus 3 times a half, that's 10/20, that's going to be 30/20. Add all those together, you're going to get 41/20, which is equal to 2 1/20 or 2.05 free throws. So that would be the expected number of free throws based on that probability distribution right there. That's called an expected value. We just calculated an expected value. Okay, so mu, the expected value, mu equals 2.05. Call that an expected value. You're wondering how I went from 1/5 to 8/20. 1/5 is the same as 4/20 if you get a common denominator, and 2 times 4 is 8. Yeah, because when you add fractions, you have to have all the same denominator. Okay. So let's have you do one here. This is the same concept, but the number of accidents in a week. I'll pause it. I'll let you go ahead and calculate and see if you get it right. All right, 0.37 is what I got. And anyone second that? Third? All right. Okay. This class is getting a little off the hook today because we did watch some middle school news episodes from 2016. 15 to 17. The golden age of middle school news was 2014 and 15. So you know. All right, keep accidental pause there. Okay, outliers, talking about how to calculate outliers. I think you know what an outlier is. We talked about this before. So some value that is much higher or lower than the average. And so there's two ways to calculate the middle, the average, and one way is by using the mean. So using the mean, or x bar, is one way to calculate the middle. And so if we're going to find and determine if there is an outlier using the mean, we are going to use the standard deviation as a measure of how spread out our data set is. So one way to calculate the outliers is to add and subtract 3 standard deviations away from your mean. So if you take your mean and you add 3 standard deviations and you subtract 3 standard deviations, you will have upper and lower boundary points that will be able to determine what your outlier, if an element is an outlier. Standard deviation is what we did last lesson. Yep. The square root of the variance, so the very last part. And then the other way is to determine outlier boundaries is if we're using the median. So if we're using the median, then we're going to use our interquartile range as a measure of spread, and that would be 1.5 plus and minus your median, plus 1.5 times the interquartile range, and also the median minus 1.5 times the interquartile range. So those are the two most common ways to calculate outliers. Let's go ahead and put them to work here. Let's say we have calculated our standard deviation and it was 7.24 with a mean of 11. Let's calculate where our outlier boundaries, upper and lower, would be. So the mean would be at 11, and so we need to take our average, our mean, and add 3 standard deviations, and then we also need to subtract 3 standard deviations. So 3 standard deviations in this case means that that would be 3 times 7.24. Holy cow. My smartboard's not, yep, that doesn't erase. Sorry. It's just the 3 is the rule. You know, and it's not the only way to determine an outlier, it's just a customary way. So 3 7.24s is going to be 21.72, I believe. And so what we do is we add 21.72 to the mean, which is 11. Crusty. And then we subtract 21.72 from the mean, which is going to give us an upper boundary and a lower boundary of 32.72. And if we take 21.72 away from 11, I'm going to get what, negative 10.72? So what that means is any element that is greater than 32.72 or less than negative 10.72 is where outliers would be. So anything over here or anything smaller on the left side would be considered where the outliers would be, based on 3 standard deviations away from your mean. Okay, so what we'll have you do on the assessment is you're going to have to determine these boundary points here by adding 3 standard deviations from your mean.
So is 32.72 an outlier, or is it like 32.73 outlier?
That would be like right on the list. That would be right on the button. It's not past that, so it would not, I mean, I don't know, it's right on the cusp. Depends if you are including it or not. I mean, depends on the definition of your outlier. The definitions of the outliers can change. And to be totally honest with you off the top of my head. I don't know if it is inclusion or not inclusion. So let me just look at what they have in our book. So hold on, let me pause it a minute and we'll answer that question. All right, so the question was, what if it's right on the line? Do you consider that an outlier or not? And I looked in the book, and the definition in the book says that wherever it was, it has to be more than 3 standard deviations away from the mean. So if it lands right on the line, then I guess we'll say that it's not an outlier technically. It's pretty darn close. It's as close as you can get to being an outlier, right? So that would be using the mean and standard deviation. Let's review how to use the median and the interquartile range. So let's take the data set 2, 5, 36, 38, 40, 42, and 100. So we have 100 is in the data, is in the list. It's just not, I'm going to write it up here so we can get more of a visual of the median. So which one is in the middle? 2, 5, 36, 38, 40. It's going to be 38, right? And so now that is going to leave the first half of our data to be 3 elements smaller than. So our Q1 would be 5, and our Q3 on the other half would be 42. So my 5-number summary would include these values, these 5 values, your minimum, your maximum, your median, and then your Q1 and your Q3. Okay. So now, based on the other definition of an outlier, it would take your median, which is 38, and you're going to add 1.5 IQRs and minus 1.5 IQRs. So what is the interquartile range? Well, the interquartile range is going to be Q3 minus Q1. And so for this problem, that interquartile range would be what? 37? Okay, so you're going to take 38 plus 1.5 times 37 and minus 1.5 37s. So, yep, you're right. That would be 55.5 and minus 55.5. So I believe that's 93.5. So 93.5 on the high end. And on the low end, I think we get into negative what? On the low end. You get 37 by taking that minus that. So it's the interquartile range. So if I drew a box plot, this is totally not like legit, but box plot would go like that, right? It has to be on a number line, so that's why it's not accurate. But the box plot interquartile range is the range from the box, the high end of the box, the Q3, to the low end of the box, right? That's how you get that 37. I'm going to erase all the evidence there. So if X is in either one of these areas outside of here, greater than here, or less than here, then it is considered an outlier. Any outliers in this data set? 100, right? 100 would be over here, and so 100 we would deem as an outlier. Okay. Yep. It just depends on what you want to use. If you're going to use the median or the mean. Sometimes when you have a value that is an outlier and it's so far away from the middle, you don't really necessarily think the mean might not be the best measure of the center, because that outlier sucks the mean towards whichever end it's on, the high end or the low end, you know. But you can always take an outlier, determine it's an outlier, discard it, and then recalculate all your data as well from that. Yeah. I can't remember. Okay, the last part to this, we're going to show you how to do this on the calculator. So if you want to grab a TI Inspire, and then I'm going to show you how to do this on there. It's pretty slick. All right, so we take our TI Inspire that we have, and you go and open up a spreadsheet, which is this icon right here. And you open up a spreadsheet, and it will give you a blank spreadsheet. This one is about baseball and runs, so I'm going to type in runs in the top there, and mine was it bolded like that because I already typed it in, so it has it saved. So when I hit enter now, all the values pop in. It's pretty slick. So the values you want to type in are going to be on this other page right here. So I'll give you a minute to type those in. All right, now we got that typed in, and now what we do next is we go to Menu, Statistics, Stat Calculation, and that gets you to the one variable statistics. Click on that. It's going to ask you how many lists you want. You just want one list. And now in that X1 list, you should be able to click in there and select what you had labeled yours, in this case runs. Frequency 1, result column B, that's fine because I don't have anything in there that I'm going to overwrite. And so everything should be good. Just click OK. And now it's going to have generated a whole bunch of stuff for us. In the second row, it generated X bar, which is the mean. So that's 5.357. This next one is the sum of all the numbers. So if you add them all up, you should get 75. That's going to be the square of all the numbers added together. And then right here we have two standard deviations. For this, we'll use our sigma. So 4.319. So they're both standard deviations. If you take stats, you'll learn a little bit more about that, why there's two. And then if you keep going down, we have our 5-number summary. So the last 5 numbers you have, well, I guess it's not the last 5, but you have 2, 3, 4, 6, and 19. So there's your 5-number summary in case you need to make a box plot. I can go ahead right now and calculate the interquartile range, right? You should keep going down and you should have the 5-number summary. Should be in row. It should be in row 8 in this problem. Yep, row 8. So if you calculate the interquartile range here, you have 6 minus 3, which would be 3. And so we could do our 1.5 IQRs if we wanted to. We could do our standard deviation up above with the mean. And so this kind of gives us all the information we need for that. Let's make a quick box plot from this stuff. So if you go and put the cursor back over to the runs column, and you go to Menu, Data, Quick Graph, that gives us a quick little dot plot of our data. I don't really like having split screens, so I'm going to do an ungroup. So I'm going to hit the dock button, which is above the menu, and then I'm going to do 5 for page layout and 8 for ungrouping. So dock 5, 8 ungroups, and that allows me to see this whole thing on one page. So there's a dot plot. You can mess around with the scale a little bit if you want, just to make it look different sometimes. But anyway, we want to change it to a box plot. So let's go up to plot type and go to box plot, and then it will just magically transform that into a box plot. So you see this 19 over here that doesn't have a bar connected to it? That is an outlier. And I think the calculator uses 3 standard deviations, because if it were to use 1.5 IQRs, the IQR in this problem is 3. 1.5 times 3 is 4.5. 4.5 plus 4 is 8.5. So that would be the upper boundary, but there's a 10 there. So I think we're using 3 standard deviations on this. Anyhow, so that is how you can calculate all that stuff you need on the calculator. So you can use these calculators on MCAs, ACTs, so on and so forth. We'll let you use them on the test, so if you want to use it to calculate or check your standard deviation on the test by hand, you can. But that's pretty much it. And I guess one last question would be this question here. Describe how an outlier affects the mean and standard deviation. Cheapers. So how does the outliers affect the mean? What does it do? What does an outlier do to the mean? It makes the mean bigger. Depends if it's a big outlier for small. If it's a smaller outlier, it would make it smaller. So whatever the mean would be, if the outlier was a big number, it would kind of pull the, it's like a tractor beam. It would pull the mean towards whichever outlier side it's on. So it does have an effect on the mean. Does an outlier have an effect on the median? No, it doesn't, because the median is just that one in the middle. If you had an outlier, you'd be like, cross this one off, cross that one off, cross this one, and you would just cross it off, and it doesn't have any effect at all. So you got to be careful. Outliers do have a pretty significant impact on the mean and the standard deviation. It would also make the standard deviation greater. So therefore, sometimes if you're using those metrics, then you would omit some outliers so they don't give you an inaccurate representation of your middle, yeah, your mean, your average. All right. Okay, signing off. All right, bye. Bye, Nat. Bye. See you later. Over 20 minutes today.